Now we'll get into the coding portion of this course. We'll create a high-level implementation of a blockchain in JavaScript to materialize what we've learned up to this point and really drive home the core concepts from a basic code up. While we'll not build something that you can create the next multi-million-dollar ICO upon, we will create a basis for blockchain functionality and see for ourselves in our own code how some of these concepts can be implemented. I like to present coding concepts with an online IDE, so your experience and mine are exactly alike, regardless of whether you're working on a Mac, PC, Linux, Chromebook, or even a tablet. The preferred online IDE for this purpose is Code Anywhere, as you can create an account and be coding in minutes. The whole experience is great, as with Code Anywhere, you code in your own virtual server in the cloud. Code Anywhere creates a complete, stacked-up environment for us to work in, so we can completely disregard the concept of localhost. This keeps our own devices from being bound up with additional development config and overhead, and leaves the heavy lifting in the cloud, where we can access it from anywhere. If you've never used an online IDE, please join me on codeanywhere.com and give it a try. Chances are you'll love the experience and consider it for further development. Of course, if you love and are faithful to VS Code, Sublime, or Atom, or whatever, that's okay too, whichever you prefer. Give Code Anywhere a chance though, if you can. To get going on codeanywhere.com, just create a free account and bring up the IDE in a browser tab. The layout should feel familiar if you've used an IDE before. On the left of the screen is a tree view of the workspace, and there is a node called Connections. If you right-click this node, options will be presented, and you'll want to click New Project. This will open up a dialog that prompts you to name this project, call it JS Blockchain, and this window also allows you to configure the single container that the free Code Anywhere account type provides. In the list of container recipes, scroll down to the Node.js on Ubuntu option and select it. Then go back to the top of the window and name the container Node.js on Ubuntu. Excellent. Click OK and let Code Anywhere configure your new server and spin it up. When it's ready, you'll see the name of the container in a new child node of the Connections node in the left-hand side tree view. We've now got a fully configured server with Node running, not to mention MySQL and Redis, which we won't be using, and we're now ready to write some code. First though, we need to initialize our node environment by clicking in the terminal and entering npm init. Then we can name our project within the node, and then default through the rest of the init questions. Great. Let's do one install while we're here, as we'll need a JavaScript cryptography library in just a few minutes. Enter the command npm install --save crypto-js. This will install the crypto.js library that we'll depend upon to do the hashing things we'll need to perform in a little while. This is a cryptographic utility for JavaScript. It will assist us as we write blockchain code in the next few videos when we need to encrypt data. I'll say now that crypto in general is hard to do correctly, very hard to do correctly. Using crypto libraries in JavaScript, or any other runtime environment for that matter, exposes a large surface for attack, and reducing that surface is a job for the experts. So, as we employ the crypto.js library, do not think in any way that we're producing a production-grade security implementation. Not at all. We're introducing the use of a cryptographic utility in our code and seeing how various encryption algorithms change string values to hash values. That's all. The efforts and techniques that the big boys who develop major blockchain systems put forward are a lifetime study and are far, far beyond the scope of this course. So with that, let's check out the crypto.js documentation. We can go to the npm.js page that describes the package. Here we can see that this is high-leveled as a JavaScript library of crypto standards. That's good, but what does that mean? As we scroll down, we can see the package is used to perform HMAC level 1 SHA-hash on messages with a key parameter. That is telling. Further down, we can see how a SHA-256 hash is performed on a string value to create an encrypted value. We're starting to get the picture here. The actual API doc can be found at code.google.com/p/crypto-js. Check it out too if you're curious. If we continue down the npm.js page, we'll see some code illustrating actual usage of various hashing functions. We can see the use of the AES cipher, where the Crypto.js object provides the static hashing method. And with AES, we can see that a key is used to encrypt and decrypt. The implementation couldn't get much simpler. Just pass the string to encrypt and the key as arguments. And the same thing for decryption. Beneath that is an example of object encryption using the AES cipher. We can see that we simply use json.stringify to format a JavaScript object as a JSON string value as it is passed into the encryption method. Then we use json.parse as we decrypt the hash to recreate the object. This is very simple usage and shouldn't confuse anyone. As we work with the library, we'll use SHA-256 to hash our objects and values for the blockchain. As we aren't using keys in our implementation, SHA-256 can be performed by simply passing the value to be hashed into the Crypto.js object's static SHA-256 single argument. This will do the job we need done, as we'll see. Okay, we can now get Angular installed and our dev server configured so we can test our code and UI as we develop. To have Angular and its CLI installed and function correctly, we need to be sure we've got the current version of Node running in our environment. This takes just a few commands. The first is to install the latest Node version. The command is nvm install node. When it installs, we can use the command nvm ls to see what version was installed. Each installed Node version is listed, and our new one is highlighted. The third command sets this new Node version as the default for our Code Anywhere instance. We use nvm alias default and then the new version number, which is highlighted in the list. This version of Node is now configured to be the default version within our environment. Okay, the fourth and final command will update our global npm version so it is in parallel with our default Node version. We use npm -g for global and npm, and this will install npm globally and will be used in parallel with our current Node default. So we let this finish. And great, Node and npm are all updated and we're ready to install Angular through the use of its CLI tool, which does so much of the Angular heavy lifting for us. The CLI is awesome and saves us from many manual processes in getting Angular up and running. The command to install the Angular CLI is npm install -g at angular/CLI. This installs a ton of dependencies and takes quite a while. When it completes, we can use a single command to have the CLI set up and scaffold a fully functioning project for us. Like I said, the Angular CLI tool is awesome. The CLI new project command is ng new and then our project name. We can use ng-crypto as the name of our new Angular project. ng is short for Angular, if you didn't know that. The CLI tool will do a number of things with this one command. It will download Angular and all of its dependencies, a ton of stuff. It will scaffold the project for us, including all of the best practice, folder structures, and config files, and will generate a simple working project that we can immediately try to run to prove our installation successful. Okay, with the installation complete, because we're working in Code Anywhere and do not have a local server for development, but instead we'll have our dev server running on our Code Anywhere virtual instance, we need to make a single tweak to the package.json file that controls our node setup. If we open the file by double-clicking on the Node.js entry in the left side tree view, we can adjust the start serve node of the scripts entry. After the colon, we add the following: ngserve --host 0.0.0.0 --port 3000, and then --public, and then our connection name, our Code Anywhere username, and then .codeanyapp.com. This indicates the dev server running at IP0000, or within the virtual host, if you will, a port of 3000, which we can use on Code Anywhere to enable HTTPS, and then the public value lines, which set up our dev server with the way Code Anywhere makes apps available from an external browser, as we'll see. With these settings all done, we can save the package.json file and fire up the server from the terminal. Let's be sure we're in the directory that the Angular CLI tool created for our app, and then we can use the command npm start, which will fire up the server. We should now be able to go to the correct URL and see our app running the simple thing that the CLI generated for us. To find the app, in this tab, we can see the HTTPS URL where our app will be found. Let's click that URL and see. And yes, our app is running properly, and we can assume that the CLI installation was successful. Great work. With that overview of our crypto package, Crypto.js installed, and Angular installed and set up, let's move to the next video where we can start building the basis of our crypto project, a blockchain class, and its accompanying block class.